is about nth term number sequences. With the number patterns that we've looked at so far, they were simply seeing a particular pattern in the numbers and working your way upwards to work out maybe the next value or a couple of values down the line. So we might have a number such as this. You can see the terms down here. It's saying that the numbers in this sequence are 5, 10, 15, 20. And before we might have looked at that and said that, well, they're going up by 5, so the next value is 25, the next one after is 30, and so on. In this case then, what we're going to be doing is labeling each of those terms as the number it is in the sequence. So if it's the first term, we say that n is 1, the second term we say that n is 2, and so on. And we need to ask ourselves, well, what happens if we want to work out the 100th term, the 1000th term? We can't simply keep on adding up 5 at a time. What we need is some sort of equation that allows us to quickly work it out for any term. So the first thing we've got to look at, here's another sequence that I've shown you, showing 6, 11, 16 and 21. The first thing we're going to look at is the difference between them. So we go into, mistakenly by here, it should say 11 take away 6 is 5. So the difference between these numbers is 5. And what we'll do is we'll put that difference, the number that difference is, in front of the letter n. So just like in algebra, this is saying multiply the letter n, whatever value that is, by 5. So if it was the first value we're talking about, it would be 1 times 5. If it was the second, it would be 2 times 5, and so on. But taking the first value as an example, 1 times 5 will just give us 5. It won't give us 6. So the next question we have to do is, what do we have to do to the 6, the 5, in order to make 6? Well, if I work out the difference, 6 take away 5 gives us 1. That tells us we have to add 1 on to 5 to get 6. So whatever number you found in front of the n, whatever the difference is, work out what you have to add on in order to get the first term. And that will now give you your equation. 5n, the 5 is the difference between the terms, and then adding 1 on, because for the first term we have to add 5 to 1 in order to get 6. Let's have a look at another example then. This time we've got 3, minus 4, minus 11 and minus 18, and the same principles are going to apply. First of all, we need to look for the difference. So in this case, I'm going to look for the difference between the two. Now, normally we would say do 3 minus 4 and work out the difference is 7. What I'm going to do is take the first value away from the second, and we'll see the reason for that in a second. We've got minus 4 minus 3 giving us minus 7. And the importance of that is we get the negative sign in front. It's telling us that the terms are going down by 7 every time. So instead of having 7n, we're going to have minus 7n. But just like with the first equation, when you multiplied in the first term, when you multiply 1 by minus 7, you get minus 7, not 3. So we're going to have to work out the difference between 3 and minus 7, which is 3 minus 7, which is telling us that there is a difference of 10. You're having to add 10 onto minus 7 in order to get 3. So our equation is minus 7 n's add 10. And you can work that, say, have a look at the second one. If we're in the second term, n is 2, minus 7 times 2 is minus 14, adding 10 on is minus 4. Exactly the second term, and it'll work for any term. So if I wanted to find out, say, the 50th term in this sequence, instead of having to go up by down by 7 for every single value, I can simply say that n is 50, and do minus 7 times 50 is minus 350. Add on the 10, and I know that the 50th term will be minus 340. So then the last thing we need to do is find the sum of the first 10 terms. Now, to find the sum, we use a special equation. We could technically add on the terms, but to do that, we'd have to work out the 5th term, the 6th term, the 7th term, and what happens if it was the first 100 terms we need to work out. So instead, we use this equation, Sn equals n bracket a1 plus an bracket over 2. Now, it sounds a bit complicated, but basically broken down, this is what it means. S with a little n means the sum of any given number of terms from the start, what we're looking for. N means the number of terms we're adding together. So if we want the first 10 terms, n is 10. A1 is the value of the first term in the sequence, and an is the value of the last term in the sequence. So going through these, we said that we want the first sum of the first 10 terms, so n is 10. The value of the first term, well, we can see from this table by here that the first term is 3, so the value of the first term is 3. And the only thing we don't know is the value of the last term, because we don't know the 10th term in the sequence. As I said, you can work your way up, but what happens if it's the 100th term? Well, our earlier process of coming up with the equation answers our problem. When you work out the equation for the nth term, like we worked out minus 7n plus 10, to work out the 10th value, we can plop that in instead of the n, minus 7 times 10 plus 10 now, which is minus 70 plus 10. The 10th term, the value of it is minus 60. So now we can go back to our big equation. We've got n is 10, the number of terms that we're looking to add together is 10. The first value is 3, and the last value, the 10th value, is minus 60. I'm going to now substitute them in. So I've put in 10 instead of the n, 3 instead of the a1, minus 60, notice how I'm keeping the plus here, instead of the an, and 2, all over 2, which gives me 10 times minus 57 over 2, which gives me 570 over 2, which gives me minus 285. So the sum of the first 10 terms in the sequence is minus 285.